Hello, we are going to be talking about the RAK2270 LoRaWan Sticker Tracker. Right here I have one of my original ones that still has a battery in it, but I've disconnected the battery. And here's one of the dev ones that I've got for my classroom. Here's my profile. You see I've got a couple of repositories that I work on. You can go through the profile. Here is the basic thing I'm working on at the moment, which is called Maker 100, where I use a couple of microcontrollers to do some fancy robotics, machine learning, IoT, a bunch of things. So we are going to look at the RAK Sticker Tracker. And the first thing I'm going to do is um, look at the two serial monitors. This one is COM4, which is this one here, and I can do a send. It's pre-set up. Oh, interesting. I thought there was nothing on this one. Um, and it's sent. Now, what I want to show you here is that's COM9. That's the one I want. Is these sticker trackers are really interesting. They've got really good at command abilities. So here I'm going to flash to the board. So let's put it into boot mode. Now these boards are interesting. There's no physical way to put them into boot mode as long as I know. So put it in, whoa, this has got different programming on. So it's in boot mode now. And I'm going to flash a totally blank program to it. I think it's all properly set up. That'll take a few minutes. But what's really cool about these boards is they have at commands in the background when you've just got this blank setup and loop. Setup activates once, the loop activates continuously. Basically, every other Arduino microcontroller does nothing. These things, which are LoRa and LoRaWan activated, and please understand the difference between the two. LoRaWan uses access points, hotspots that are in most big cities around the world. And you either use the Things network and get on for free in some situations, or you use Helium, which is crypto, and you get on very inexpensively. I think you get like 10,000 data credits for free just for trying it out. And each one of these sends is going to be like 2 data credits. You can actually do quite a bit. Okay, so what we are going to do is on COM9, this one, we're going to put that blank, and then I'm going to go through these commands. So at network mode equals 0, meaning LoRa, not LoRaWan, which is 1. Then we're going to check P2P. It should look something like this. Then I'm just going to double check the P2P receive. I don't know what the V stands for. But I'm going to set it to be 0 and then set it to be this interesting one, which isn't really talked about that much. It's send and receive. So here we go. It looks like it's active. ATZ just sort of gets it going. Yes, we are in LoRa P2P, so we didn't actually have to do NWM equals question mark. And it should say 0. There it does. So we know the first setting is good. Then at plus P2P, and it doesn't have to be capitalized. It is standard. Ooh, that's not good. Equals question mark, and there we have it. 911. And these I should know what they are, but we're as long as both match up the same, we're good. So that's 7, 0, 0, 8, and 14. It's channels and spreading factors and stuff like that. Okay, so I'm going to just test this receive V. I'm actually going to ask what it is. It's off. That's good. That's exactly the same as doing 0. Let me prove that. See, it's off. Now, I don't want it at that. I want it on 65533. And now if we run that, it's on. But this is an interesting on because say hey, I think I can copy this. So let's first see if it'll send. Yes, it sent that command. And let's go back here and see if it'll send. Yes, it sent the command. So what you can do now is LoRa has a distance of about 2 kilometers in the city. 10 kilometers sort of line of sight in the country, but it can go up to, I think the best is 1,300 kilometers. This stuff is insane for distance travel. Um, so that's kind of what I wanted to show you. What I'm going that we can just kind of communicate back and forth. Now, by the way, this is 41 is A, 42 is B, 61 is small a, 62 is small b, 20 is space, 7a. Anyway, if you wanted to communicate, you could use this. And I get my students to write their name in this format. So what I'm going to do now is I'm going to go to RAK send 08 receive. I might change this code a little bit, but here it is. I'm just going to copy that code, and then I'm going to put it on both these machines. I don't think you need to see. Oh, the one thing you do need to see is that we must go at plus boot. So that one's in boot mode. This one at plus boot. And that one didn't work. At plus boot. That one's in boot mode. So I'm going to pause. And okay, so I've fired the code onto COM4. Now let's put it on COM9. I don't need to save that. So what's here? Just some information showing the RAK DAP, which is this thing, and the board, well, in this case, the board that has the RAK clip. So VCC, ground, TX, and RX. One thing with UART is RX goes to TX and TX goes to RX. This has the little U in front of it for making sure you're dealing with the right thing. Then a repeat of these commands up here. And then the code, and the code's simply complex for how little it's doing. It's just changing those numbers into actual words. I might change the code a little bit. I had some problem with the at commands, not really working with the send and receive. But this part's kind of interesting. I give a few seconds at the start of programs running in case I screw up the at commands. If I throw in a while loop, which doesn't give any chance for the processor to read the at command, it basically locks up the computer. In this case, the RAK. You can use an ST link v2 and get it all back together, but it's best just to have this little starting thing. Now a reminder, okay, that's compiled, and it actually takes a fair bit of time to load it up. A reminder, these things, once they're programmed, they just need power. They don't need connections. The serial monitor could be the accelerometer, could be temperature, could be voltage, can be all kinds of stuff. These are really quite capable little boards, and they're $14 US. So it looks like we're up to date. Let's just reset it. ATZ. There we go. We got our, oh, that's actually running quite well. Let me try this again. ATZ and then do it again. There we go. So now it's doing the countdown. Let's try this one. ATZ. That's interesting. That did not fire. Okay, let me see what I've done. I will pause for a sec. Okay, so I thought somehow I didn't compile it properly, but the issue was this little power pin just came apart. Okay, so we have COM4 running here, done the same thing, the 4 or 5 seconds. Now, theoretically, I could go through and test everything, but theoretically, these are now both in send and receive mode. So I'm just going to put a low in this one, and let's just try it again. And that was less than exciting. Let's try this one. Okay, that one sent here. Okay, and not quite sure what's happening over here. So goodbye. There we go. Now, see what's different here? It's telling me what command was sent at psend 47 blah blah blah, and it's writing goodbye. Here it's simply writing sending goodbye because you can go check. Oh, no, you can't. Oh, it actually told me that looks like that looks like the hello. So let's just try some other ones here. Fred, done. Yeah, it doesn't tell me the psend command on that side, but it does on this side. Anyway, here, Mary. Now, these are like radios. They're like text messaging radios for $14. Um, Anyone within the area would be able to send as long as you had exactly the same settings, these P2P settings. So the 7, the 0, the 0, the 8, and the 14 might change what's going on here. You can also encrypt these. Each board needs an encryption key. But that's the basic thing is these things can send messages, text message, without a SIM card. You know, they're just the boards, and they can go 2K in the city, 10K line of sight in the country, or up to 1300K over water sometimes. Yeah, I think that's about it. Oh, I didn't actually go through the code. Um, Here's my setup. Here it's just checking that we are actually on network mode 0. It reboots and then comes through. If network 0, then it doesn't reboot. It's setting up the 2 callbacks. There's one of the callbacks, and I think the other callback's just blank. Basic, just grabbing stuff, doing buffer stuff, printing it. The main loop, I can't quite remember why there's even a start time thing here. That's kind of interesting. I don't think I've actually used the start time at all. Yeah, that's from whatever program I got the original stuff from. Now, I did have a bit of a problem with at commands here. If I had a delay in this loop, the at commands worked. If I didn't have a delay in this loop, it sent properly. So what I threw in was I grabbed the serial monitor read string. If it had a capital A or small a in the first spot and a capital T or small t in the second spot, then it did this stuff with a delay so it could read the at commands. Some of the at commands seem to work directly, some of them don't. And then if it didn't have at the start, it would do the sending information. And that's all the code. Hope you enjoyed it.